All right, welcome everybody. Let's do this. So let's cover the last four questions, 7, 8, 9, and 10, and we're done. So here, the question is saying, classify each variable as discrete, continuous, or neither. So before we actually go into that, let's just look at the definition and the concept. And the definition for the textbook states that it's quantitative data values that are countable, that's for discrete, and continuous are quantitative data values that are not countable. So that idea of countable and not countable comes up in higher levels of math, but the definition is pretty bad. But I'll show you some examples to show you what we mean. So here, when we look at discrete, I want you to think of scenarios where we have whole numbers. For example, something that would be discrete would be like the number of ice cream cones an ice cream truck has. An ice cream truck has. Here, notice that how many ice cream cones could you have in a what are the date? I'm sorry. How many ice cream cones can you have in a truck? Like maybe you could have like 30 ice cream cones or something. But you could have 31 ice cream cones. You could have 140 ice cream cones. But you can't have like 30.5 ice cream cones. That's not possible to have. You don't show that kind of. You don't show that you have 30 and a half ice cream cones. You want to say you have 30 or 31. So notice that when we talk about ideas that are discrete, we want to think about concepts with whole numbers, right? Like, do I have 4 of something or 5 of something, but not where I could have like 3.5 of something, right? Let's look at the idea of continuous. Here, let's look at weight. Imagine if we're talking about firefighters. And for a firefighter's weight, you have to be between 150 and 250 pounds. But any firefighter could be, let's say, 151.2 pounds or 151.23457 pounds, right? A firefighter's weight can be anything between 150 and 250. But example for here, for ice cream cones, with this idea of discrete, you can't be 30.5, you can't have 30.5 ice cream cones. So here, when you're only talking about whole numbers, that's the idea of discrete. Continuous says you have everything in between. And this is the concept that I had here with these symbols, that this is the set of integers that are, like 0, let's include 0 as well, but positive. And here, this is like the real number line. So ideas that are continuous are like temperature. Temperature could be like, you can be 98 degrees Fahrenheit, or you could be 98 degrees 0.1 Fahrenheit outside, or something like that. So you have you have every number between your set of numbers. Age is another one. Like you could be 20 years old, or you can be 20.1 years old. Okay? So let's look at these examples over here. Here, let's look at this one. Number 1. It says the number of donuts sold each day at Donuts Heaven. Is this an idea of discrete, continuous, or neither? Here, when we're talking about donuts, you're going to have like, let's say if I want to go and get donuts for my friends, I would say I'm going to get like 7 donuts. Right? But I'm not going to say I have like 7.2 donuts. You're not going to buy 7.2. You're going to buy a whole number of donuts. So this one, we're going to say that this is discrete. This is an idea of discrete. Here, for letter B, it says water temperatures of 6 swimming pools in Miami on a given day. Here, when we talk about temperature, this idea is going to be continuous, because for a swimming pool, I could have my temperature be, I don't even know what a temperature, what would it be? Like maybe it'd be, I don't know, like 80.5 degrees Fahrenheit, right? Or 80.6 degrees Fahrenheit. But yeah, because here you have everything in between your data values. Here, let's look at C. It says colors of baseball caps in a store. So this idea would be neither, because what constitutes colors? You have like blue, you have red, you have green. Here, these are not numerical values. You don't have the concept of whole numbers or the real number line. You don't have this concept here. So here, notice that these are quantitative and this is qualitative. So when we have ideas that are qualitative, it is neither, because we don't have numbers here. Okay, so that's it for question 7. Let's look at question 8. Here you have, before we do question 8, let's just kind of get some idea of what we're talking about. So here, let's see. I drew this out for us, and this is the empirical rule for data, that if this is my standard, this is my mean, and if I'm one standard deviation to the left or to the right, then I'm going to say that 68% of my data falls within one standard deviation. If I wanted to look at, so from here to here, we're going to say that this is 68% of your data. Here, if I want to go 2 standard deviations, and we'll show this in the pink, we're going to say that this is 95% of our data values. So this is 95%. Okay? And for the last one, here for 3 standard deviations from the right or to the left of the center, then we're going to say we are, then we have 99.7% of our data values. So then this is, right? And then here, just for a little, what would this, how much percent of our data values do we have here? That notice that the whole thing has to be 100%, right? When you talk about all the data values you have. So this whole entire, the area of the bell curve is 1 or 100%. So here, if you have 99.7% of your data values from here to here, then what's on the green to the side has to be 100 minus 99.7. So that's equal to 0.3%. And if I divide that 0.3% by 2, I have 0.15% on each of these sides. So here, this should be 0.15%, and here we should have 0.15%. Okay? Some notes to have in your book. But let's go and see how this could help us for our problem over here. Let's take a look. So here for question 8, the first idea you want to understand is that we're going to have a bell-shaped distribution. And what information do we know? That the mean is 515. So let me zoom in a little bit. Okay, so the mean is 515. So what does that mean? That if I'm over here, the center of your data value, this has to be 515. And if I know that the standard deviation, so if I know x bar is 515 and s is equal to 114, so if I go 1 standard deviation to the right, I have to do 515 plus 114, so that's 629. And if I go 1 standard deviation to the left, then this is 514 minus 114, and that's 401. Okay? Now let's look at question A. It says, approximately what percentage of SAT scores is between 401 and 629? So here, if we have some normal distribution, then everything in between 401 and 629 satisfies this condition. So then here, this is just going to be 68%. Because we have to use the empirical rule for data that if you're 1 standard deviation from the right or from the left, you usually 68% of the data is within that standard deviation. Okay? Let's look at the next one. Here it says approximately what percentage of scores is less than 401. So let's see, the pink we'll use the pink for this one. Here it says what percentage of data values, or what percentage of the scores is less than 401. So what's less than 401 is everything here. okay, or greater than, or greater than 629. Okay, so if you know, think about how you would solve this. If you know that the whole entire thing is 100%, and if I want the pink, like what percentage this is, if I know the blue is 68%, then to get the pink, I just need to do 100 minus 68, and that's just equal to 32%. And that's it. All right. So here, for this one, it's just 32%. Okay, let's go to question 9. Here, question 9. This is it over here. All right. Here, let's look at this. Let me zoom in closer. It says a student scores a 60 on a math. Oh, okay. Before we actually do this, let's look at what we're talking about here. For this question, we're going to need to understand the concept of a z-score. So here, x will be the data value that we're plugging in, x bar will be the sample mean, and s will be the sample standard deviation. So here, let's see, a student scores a 60 on a math test and has a mean of 53 and a standard deviation of 3. So when I want to plug in this, when I want to write down what this information is saying, it's saying that he scored a 60 on the math test, the mean was 53, and the standard deviation was 3. Here, for the other part, it says on the history test, he scored an 80, the mean was 75, and the standard deviation was 2. So we want to see, like, maybe a 60 on a math test is with a mean of 53 and a standard deviation of 3 is better than an 80 with a mean of 75 and a standard deviation of 2. We want to see which test did he do better on with respect to his class, right? And that's what a z-score does for us. So here, we just have to plug in the value. So this is going to be 60 minus 53 over 3, and this is going to be 80 minus 75 over 2. You could just put this into your calculator, but here this should be 5 over 2, which is 2.5, right? So this is 2.5. And now here, this one is going to be 7 over 3, which is 2 1/3, which is 2.333 bar, right? And notice, which test did he do better on with respect to his class? It would be this one, because he's farther away from the mean. So the history test he did much better on. Well, not much better on, but just better. Okay, last one and we're done. Here we have a scatter plot below. Let me fold this real quick and look at this question. Okay, so here, let's look at, consider the scatter plot below. Which of the following could be the value of R? So notice that the values of R here, well, what does R mean? What is R? R shows you how close to, if I were to draw a line from here to here, let me zoom in a little bit. If I were to draw a line from here to here, like if I were to draw a line that best fits, this would be my line that best fits. R calculates how close the data values are to the line. So because, number one, that the slope is positive, right? Because if I have a line like this, my line is positive. If I have a line like this line is negative. Okay, so here notice that our line is positive because it's increasing from left to right. And how close are the data values? The data values are very close. And when we talk about the strength of R, we always have this range of between 1 and -1. And here, because we have a positive slope and the data values are very close, this is going to be something very strong. So the R value of this has to be close to 1, the positive one. And which one of these choices has a choice of close to +1? It'll be this one. Okay, so this would be the best value for R in terms of these data values. When we look at part B, it says given the regression line has a slope. So what is the equation for a regression line? It's right here. It's this y hat. The way you read this is y hat, and the way you read this is a b naught, and this is b sub 1 x, right? So here, this y hat is equal to b naught plus b sub 1 x. Here, it's very close to the equation of a slope, right? The equation of a, I'm sorry, equation of the slope. Equation of a standard line, the equation of a standard line. So here it's on y is equal to mx plus b, but here it's kind of switched, where this b value is the y-intercept, or this b naught, and this m is the slope represented as b sub 1. So here for this problem, we just have to find what each one is. Here the slope is stated to be 6.458, and the slope is b sub 1. So b sub 1 is 6.458. Let me use a different pen real quick. So this is 6.458. Here, what's your b naught, which is the y-intercept? It says a y-intercept of 51.202. So all you need to do, it says find the slope-intercept equation of the regression line. You're literally just plugging these values into the equation. So you just say y hat is equal to b sub naught, which is 51.202 plus 6.458x. And this is the answer for part B. Okay? For part C, it's saying that use what you have in part B to predict the value at x equals 8. So if x equals 8, you just have to plug in x equals 8 in here, and you get y hat equals 51.202 plus 6.458 times 8. And if you put this into the calculator, I didn't get a chance to do that, so let me do that right now. So if I have second quit, let's get out of that. That's 51.202 plus, let me zoom in, plus 6.458 times 8, and that equals 102.866. So 102.866. So when you plug in x equals 8, this is your y value, and that's it. We are done. Terminamos. So I hope this video helped. Study hard and prepare for your test. If you have any questions, you could email me, and yeah, okay, see you.